So good day, I am Jessa Mae C, Candelaria, and today I'll be presenting my thesis study entitled 7 N-Nitrosamine in Foods from the Taiwanese Market, Modified QueChERS Sample Preparation Method via Liquid Chromatography Tandem MS Analysis. Let's begin with the introduction. Nitrates and nitrites are commonly used in processed meats like bacon and sausages. These compounds can occur naturally in certain vegetables, such as spinach and celery. Moreover, with their increasingly busy lives, people opt for pre-cooked meal, fast food, or easy-to-prepare options, which often contain high amounts of preservatives. Nitrosamines are organic compounds under N-nitroso group. They are created between nitrates or nitrites and certain amines in the nitrosylation reaction. Especially it is when a secondary alkyl or aryl amine gets protonated due to the acidic environment. The nitrosyl cation then reacts with the protonated secondary amine to form the N-nitrosamine. Nitrosamines are categorized into two types. So we have the volatile and non-volatile nitrosamine. Volatile nitrosamine makes them particularly concerning in certain environment and industrial contexts where they can be easily dispersed and pose health risks. On the other hand, non-volatile nitrosamine do not evaporate easily. Their stability can lead to prolonged exposure and potential accumulation in the biological system, presenting a different set of health challenges. Nitrosamines are not stored in the body in the same way the other chemicals might be. Instead, they are typically metabolized, excreted, or interact with cellular components, potentially leading to harmful effects. The International Agency for Research on Cancer, or IARC, classified these compounds based on their human carcinogenicity level. As you can see, for VNAs, they are most classified as Group 2A and Group 2B. Group 2A is probably carcinogenic to humans. They have stronger evidence in animals, limited but more indicative evidence in humans. Group 2B, on the other hand, are classified as possibly carcinogenic to humans. They have limited or evidence to humans, insufficient or less convincing evidence to animals. Given these considerations, my problem statement is the absence of efficient food preparation methods hinders the proper determination of N-nitrosamine levels in foods, leading to uncontrolled exposure and increased public health risk. To address this issue, the study aimed to analyze the concentration of 7 N-nitrosamine in foods available in the Taiwanese market. Specifically, it is to measure the concentration of levels of N-nitrosamine in the selected food samples using the QueChERS sample preparation method by liquid chromatography tandem MS analysis. Moreover, it is to analyze the effect of specific N-nitrosamine based on food sample categories. With the stated objective, the study carries a substantial significance. The application of the modified QueChERS method enhances the efficiency of food analysis, enabling a reproducible methodology, thus providing an alternative method for a more rugged and robust analysis of nitrosamine. Furthermore, the study is fundamentally aligned with the United Nations Sustainable Development Goals, SDG 3, Good Health and Well-being, and SDG 12, Responsible Consumption and Production. The result of the study can be used to supply critical data to public health authorities, providing avenues for the creation of stricter regulations and food safety policies. This research may also advocate for safer production practices and empower consumers to make informed, health-conscious choices, thereby increasing consumer awareness about the presence of this nitrosamine in their diet. Given the significance of the study, it is important to know its scope and the limitations. The study findings may not reflect the presence of other nitrosamine beyond the 7 selected compounds, since I only used here the EPA 521 nitrosamine mix. Moreover, the sole reliance on the QueChERS method may overlook nuances in the sample preparation and analysis achievable with alternative method. Analysis will be restricted to food available in the market, potentially limiting the generalizability of the finding to other sources or regions. Qualitative analysis may be constrained by factors such as the sample matrix effect, calibration standard, and detection limits. Here, I only use the solid sample matrix. The study findings may also not capture seasonal or geographical variations in N-nitrosamine levels in food samples. Next is the methodology. First, I source my sample. Then for the sample preparation, I homogenize and remove the fat of the samples. Then next is the nitrosamine extraction. This is the QueChERS method. Then after that, I prepare solutions. So I have 3 solutions: the matrix calibration solutions, BQPP solutions, and mobile phase solutions. For the matrix calibration, I make use of 7-point calibration curve. So after preparing the solution, I analyze my sample, and after that, I analyze my data. So here it's a specific method for the QueChERS method. So QueChERS stand for quick, easy, cheap, effective, rugged, and safe. Here I make use of 200 microliter 10 ppm internal standard, 10 ml water, 10 ml 0.1 formic acid, and acetonitrite. Here are the sample categories. So we have here the food readiness, food processing, food method preparation, exogenous additives, and meat type and composition. So now let's proceed with the result and discussion. First category, we have the food readiness. So NRPE are foods that require prior cooking or any additional processing before consumption in order to eliminate possible health risks. So among the sample obtained, we have samples 1 to 70. As you can see from the table presented, NMEA was found dominant across all NRPE samples. However, it was NPRYR that showed the greatest concentration among all of the NEs. The relatively low Na in NRTE is attributed to the fact that these samples have limited parsing, lower exposure to high temperatures, and minimal use of nitrate-based preservatives. The average sum of all NAs for NRTE samples were found to be 3.44 microgram per kilogram. Now we have the RTE, or ready-to-eat samples. These are foods that you can eat right after you bought it. In the sample obtained, samples 18 to 41 are cooked products from local markets, which are classified as RTE. Same as NRTE, NMEA was found the most common, yet it was NPYR that showed the greatest concentration. Moreover, the average sum of all NAs for RTE was found to be 7.39, which was substantially higher than NRTE. This is likely due to the industrial processing techniques, addition of nitrite and nitrates, combined with high temperature exposure during the processing. So food processing methods significantly influence the formation, concentration, and reduction of nitrosamine. UPFs, or ultra-processed foods, are foods that undergo extensive industrial modifications, such as the addition of preservatives, flavor enhancers, and texture modifiers. These additives improve their sensory properties and prolong the shelf life, while simultaneously increase the nitrosamine formation during the processing. So as you can see from the figure presented, local jerky contains the highest Na, followed by sausage, packed jersey, and canned meat. The process methods such as dehydration, cooking temperature use, and search time is the reason why the jerky sample contained the highest nitrosamine accumulation. There are two types of jerky here: the classic jerky sold in the local market and the packed jerky sold in the convenience store and supermarkets. So the manufactured packed jerky contains controlled amount of preservatives, which are part of the standard limit set by the government. Moreover, it undergoes controlled condition and monitored process, ensuring better quality of the product. On the other hand, the local jerky involved prolonged exposure to smoke while maintaining high temperature, inconsistent peak type, and processing method, as well as inconsistent amount of preservatives. Specifically, NPYR dominates all the NAs found in UPF samples, showing consistency with the prior studies, indicating that NPYR can be formed easily and readily in processed meat due to nitrate curing and thermal processing. Food preparation, specifically the cooking method, significantly influence the formation and the concentration of N-Nitrosamine. So here we categorize food based on the terms of heat contact. First is the direct heat cooking. These are foods that are cooked in direct contact with heat source, making use of high and concentrated heat energy, making the food cook quickly. On the other hand, indirect heat cooking makes use of gradient or convective heat and low or more evenly distributed heat, making the food cook slowly. Foods prepared by direct heat cooking method contains higher Na concentration than indirect heat cooking. Pan frying leads to highest total nitrosamine content, followed by smoking. Pan frying is commonly done at high temperature, leading to the degradation of Na precursors present in the food. Smoking also leads to an increase in Na content, as smoking exposes meat to combustion byproducts, facilitating the nitrosamine formation. Exogenous additives. First is the black pepper. The addition of black pepper leads to the decrease in NPYR, NPIP, and NMEA. In a prior study, Salan et al. Found that the amounts of black pepper had no significant effect on NPYR levels across different cooking methods. However, in the presence of sodium ascorbate, the concentration changes. Adding black pepper in the absence of sodium ascorbate significantly increases the NPYR, whereas in the presence, the NPYR decreases. The difference is due to the synergistic effect between the phenolic compounds in black pepper and the sodium ascorbate. Based on this, given that a decrease in NPYR was observed, it is safe to say that the samples also contain sodium ascorbate. The same study found that in specific levels of black pepper, between 5 to 10 gram per kilogram, reduced NPIP content, which may indicate that the black pepper added are in samples are ranged between these amounts. The NMEA, on the other hand, is affected by the presence of piperine, where it decreases in its presence. Aside from that, the reducing compounds present in black pepper, such as the phenolic amines, acid, and flavonoids, play a significant role in the nitrosamine mitigation. Next is the cheese. The data demonstrated the concentrations of NDBA and NMEA increased, while NPIP concentration decreased. The observed nitrosamine variations can be attributed to the multiple compositional factors within the cheese. Secondary amines found in cheese interact with the nitrites, facilitating the nitrosamine formation. Biogenic amines, particularly the putrescine and cadaverine, serve as a critical precursor in the chemical process. Fat content in chemical cheese significantly influence the nitrosamine dynamics, where NDBA formation correlates with high fat content. NMEA originates from the methyl and ethylamines inherent in biogenic amine structure. NPIP formation is inhibited by cheese antioxidant components, including vitamin C and bioactive peptides. Next is the alcoholic beverage. While some beverages may promote nitrosamine formation due to ethanol and reactive nitrogen species present, others may inhibit it through antioxidant and pH modulation. In prior study, alcohols such as ethanol and methanol inhibit the formation of NDBA and DA from sodium nitrite at pH 3, but promoted their formation at pH 5. This trend was specifically observed in alcoholic beverages like whiskey, sake, and wine. The findings of the study are parallel to the aforementioned study, as NMEA was not detected in sausage sample containing sake, as well as the sparkling wine. However, the opposite trend was observed in sample containing the sorghum wine. This suggests suggests that certain compounds unique to sorghum wine, possibly the biogenic amines formed during fermentation, may contribute to the NNEA formation. Among the three alcoholic beverage analyzed, samples with the Southern wine showed the highest NPYR concentration, which is due to high amino acid content of this wine. Moreover, it indicates that the fermentation-derived compounds in Southern wine, such as the aldehydes and organic acid, may promote the NPYR formation during the sausage formation. Lastly is the hot spices. These seasonings, particularly the spicy ones, influence the formation of N-Nitrosamine. Capsaicin is the active compound in spicy seasoning, has antioxidant properties that can help prevent nitrosamine formation by scavenging the reactive nitrogen species. Moreover, capsaicin may interfere with gut microbiota, reducing biogenic amine-producing bacteria, which in turn will indirectly lower the precursor of the nitrosamine. The combination of these antioxidants greatly inhibit the formation of nitrosamine, making them beneficial for consumers. In chicken samples, NDBA and NNEA and DPA decrease with the addition of spicy seasonings, while NPYR decrease. In pork jerky, NDBA levels drop, but NNEA and NPYR increase. Although capsaicin is expected to reduce nitrosamine formation, some nitrosamine is increased instead. This difference may be attributed to factors such as meat type and composition. Choosing the appropriate type of meat and its composition plays a crucial role in lowering the nitrosamine intake. The figure demonstrates that red meat contains higher overall nitrosamine levels than white meat. Red meat, such as pork and beef, contains high levels of heme iron, which catalyzes the formation of N-nitroso compounds. According to the study conducted by Ostinger, it showed that a higher heme iron intake is associated with an increase of colorectal cancer due to the enhanced nitrosamine formation. Red meat has a higher fat content, especially when subjected to temperatures and cooking methods, and also the interaction of fat, protein, and heat can promote the formation of this nitrosamine. Specifically here, pork contains higher amount of NPYR, which is often associated with the presence of proline and hydroproline. These amino acids are abundant in collagen-rich tissue, and DBA is influenced by lipid oxidation and secondary amines, which are prevalent in pork fat. The greater interaction between ethanol amines and nitrates in pork meat increases the NNEA formation. In contrast, NPIP calculation shows that the opposite trend, with beef having the greater concentration. This indicates that fiber-derived compounds may be more abundant in beef due to different muscle structure between the types of meat. Notably, NDEA was only detected in pork, suggesting a link to precursors found in pork fat and muscle protein that are not as abundant in beef. However, these findings deviate from some studies that shows that NDA should be also present in pulse meat. As for white meat, duck samples exhibited higher levels of NDBA and DPA compared to chicken, while NMEA and PIP were greater for chicken samples. This difference may stem from the fact that both ducks and chicken meats are susceptible to contamination. So here are the equations we can use to calculate the risk assessment of the nitrosamine. So we have the LADD and the carcinogenic risk estimation method. So I tabulated here the slope factor that you can use for the aforementioned formula. Now, the conclusion. So to conclude, there were significant differences in nitrosamine concentration among food samples. So here, ready-to-eat food, specifically the ultra-processed food, contains the greatest amount of nitrosamine. Moreover, the locally produced jerky contains high Na due to the inconsistent addition of preservatives. Pan frying, which is a direct heat method, also causes the high nitrosamine content. Red meat also shows high Na content due to high in iron and high fat content. However, for the effects of additives, there are varying effects depending on the specific types of additives. And the most prevalent nitrosamine was found to be N-nitrosopyrrolidine or NPYR. And to conclude, the variability in nitrosamine formation can be attributed to the food type, inconsistent processing, preservation methods, and cooking techniques. For the recommendations, while this study provides valuable insights into contamination in food, further research is determined to deepen our understanding in its prevalence, formation mechanism, and health risks. The following recommendations highlight key areas for future studies to build upon and enhance existing knowledge in this field. First, for future research, you should analyze a wider range of nitrosamine and food substrate. Next, make use of alternative sample preparation techniques aside from QueChERS. Next, perform longitudinal studies in order to determine the seasonal variation and storage conditions. Aside from that, perform dietary exposure examination and risk analysis models. Moreover, develop mitigation properties, specifically food processing modifications and preservation methods. Thank you for listening, and God bless.